Okay, let's begin with the second option question here, please. So I'm going to move it to a whiteboard. Aha, there we are. Let's read it and begin with it, please. So the diagram shows part of the curve y equals to x squared ln x, crossing the x-axis at q and having a minimum point at p. So find the value of dy dx at q, you see. Aha, so this crossing the x-axis at q means, then this statement means x-intercept. Okay, now how do you find the x-intercept? So we put, let's say, to the part 1 here. So we put the y equals to 0 to find the x-intercept. Solve the equation. So that means x squared ln x equals to 0. Aha. How do we solve this thingy? This part. So this means ln means this is x to the power of x squared. So actually the x squared cannot be 0. So ln x part must be 0. So from which we can deduce that, because ln x is just log base e, isn't it? So base e x equal to 0. So we just do an anti-log of that. That means we'll get the value of x as e to the power of 0, or x is just 1. Okay, that means here is 1. Huh? That's the meaning here. Oh, so they're not asking for this. They're actually asking find the dy dx at q. So we found the x is 1. That means we need to evaluate the dy dx and x equals to 1. Okay, let's do that part, please. Okay, put a box around this thing. So from here, we're going to use this to compute the dy dx. So use the product rule, please. So let u equals to x squared. Function likewise, v is ln x. Differentiate each separately. Du dx is 2x. dv dx is ln x. When you differentiate, becomes 1 over x. The log, please take note. Ln x is 1 over x. Yep. Okay, then we use the product formula. Let's do that. So dy dx will equals to u dot dv dx plus v dot du dx. Let's substitute each part. So x squared dv dx is 1 over x plus v is ln x and du dx is 2x. It's just a matter of rewriting now. Then we'll get it something like 2x ln x plus x. So evaluating at x equals to 1 means, so I can write something like this dy dx notation style, x equals to 1 like this. Okay, let's compute it, please. So 2 times 1 and ln of 1 plus 1. So this is 2, ln 1 is 0 plus 1, which is equals to 1. So the answer, dy dx value at q, isn't it magically also 1? So the value is also, actually seems to be 1. Okay, let's do the second part, please. Likewise, let's check and see how to do that. So I'm going to clear this up. Please take note to have more space. Let's clear this and write. So show that the x coordinate of p is 1 over e, let's say. So I may need something from here, I guess. The dy dx is 2x ln x plus x, 2x ln x plus x, 2x ln x plus x. So we're going to use this because the x coordinate as p, as you can see, this is a minimum point. At a minimum point, the dy dx is actually 0. So basically, we're just evaluating this part at the point by putting it equal to 0. So let's try to solve that part and figure the value out, please. Sorry. Plus x equals to 0. So we factor out the x. So 2 plus ln, sorry. See, 2x ln x, please. That means 2x ln x. Accidentally wrote it. Okay. So here should be, when you factor the x, should be 2 ln x plus 1 equals to 0. 2 ln x plus 1. Cut it in. 2x ln x plus x. Yep, I'm correct. So x cannot be 0 because you can see that it's to the right here. It's a bit more than 0. Since x is not 0, the second factor must be 0. So all this must carefully reason out, depending, because the diagram given, so we can use that part to determine that part from the diagram. So ln x is -1/2, and as before, it's base e. That means when you write an anti-log, this should be x equals to e to the power of -1/2. Okay, we don't need to simplify. This is a constant. Please take note. Sometimes it's a useful trick. So then e to the power -1/2 means it's just e to the power half 1 over e to the power half, sorry. That means it's just x equals to 1 over square root of e as claimed. Because it says show that. So this part is term QED. Okay, find the dy double integration value at this one. So let's clear this first. And we'll use the dy dx part only. 2x ln x plus x. 2x ln x plus x. So that means, again, we need this part. 2x ln x plus x. So we need to do the UV. A bit of a nice trick like that. So before we do the UV, if you want to do it like this, it's okay. It's a bit of a nice trick you can apply, I think. Now, I do the normal way because the dx is easy on the other side. That means just take this as second differential. Cut it in. So this is a constant 2. Differentiate, I just put it to outside, x ln x. What I'm doing is I'm differentiating x ln x. If it helps, you can also view it like this, like x equals to u, ln x equals to v. Maybe I'll just do this part so it's easier for everyone. So differentiate respect to x. Is u with respect to x is 1. dv dx is 1 over x. So that means what I'm trying to say is this is u dv dx plus v du dx. And then here, 2 of that constant dy plus differentiate of x against dx. Either you can write it there or differentiate straight away. Just want to show that the two components here. Stressing on that. Okay, let's do that first. So u is different. You write u first, so which is x, and then dv dx is 1 over x. Then we write the v plus v is ln x. So bracket around, I'm not sure, just put it in bracket. Differentiate the dv dx is 1. Differentiate this is also 1. Differentiate x with respect to x. Okay, let's calculate all of this, please. So this is 1 plus ln x. And this is plus 1. Okay. Color change to that. Now, let's multiply out. So this becomes 2 plus 2 ln x plus 1. So this same as just telling 2 ln x plus 3. Second differential. So they say they want to differentiate it at p. So let's do that part first. So at p means the x coordinate is this. That means x is just e to the power -12 as before. So d square y, second differential, evaluated at x equals to e -12. This equals to the 2 of ln. The value of x will be e to the power of -1 over 2. So plus 3. So then this becomes, please take note, ln e like that. It means that the power can move to the front. -12 like that. The power of e like that. By the logarithm law. Ln e then plus 3. But we all know that ln e is just 1. I'm just going to write here. Because log n, this thing is the same, the base. It means the log of e like that is 1. And where the base is the same. So it's just 3 minus 1. Just 2, -2. 2 and 2 times half is just -1. So the answer, I believe, should be, the value should be, the answer, final answer should be 2. Thank you.